Dear students, today we will discuss some more theorems on the continuity. Nomenclature of this theorem is intermediate value theorems. First, I state if a function fx is continuous in closed interval ab and value of the function at endpoints at a and b are not equal, then fx assumes every value between the f of a and f of b at least once in the closed interval ab. So before proving this theorem, we should know meaning of every word. If function is continuous, it means you should be familiar about the continuity in closed interval ab, and f of a means value of the function at a. Similarly, at b, value of the function at a and b, which are endpoints, are not equal. Then fx assumes every value between the f of a and f of b at least once in the closed interval ab. So, to prove this theorem, since given that f of a is not equal to f of b, so by trichotomy rule, either f of a will be less than f of b or f of a is greater than f of b. Let u be any number between f of a and f of b. So we can write symbolically f of a less than u less than f of b, or you can say f of a greater than u greater than f of b. Let us consider a new function gx equal to f of x minus u. Now at x equal to a, g of a is equal to f of a minus u, and at b, g of b is equal to f of b minus u. Since fx is continuous in closed interval ab and u is a constant function, every constant function is always continuous function in every interval. So f of x and u both are continuous functions in the closed interval ab. So some difference, multiplication and division are also continuous function by theorems. So here we can say gx is also continuous function in AB. It is a very important concept. Now let us consider f of a less than u less than f of b. We consider first. From this inequality, f of a minus u less than 0. So f of a minus u means it is nothing more than g of a. So g of a less than 0. And from this g of b, we can say f of b minus u greater than 0. Now, g of a is less than 0, g of b greater than 0. So, by simple rule, product of g of a and g of b is less than 0. Now, by the theorem, we state the theorem fx is continuous in closed interval ab and f of b and f of b are of the opposite signs. Then there exists at least one point C belongs to open interval AB such that f of C equal to 0. So implies that since g of A, g of B less than 0 implies that there exists a C point belongs to AB such that g of C equal to 0. G of C is equal to 0 means f of C minus u is equal to 0. So imply that f of C equal to u. So fx will assume every value between f of A and f of B at least once in the open interval. So this is the complete proof of the theorem. Thank you.